So I've brought up Wireshark and you can see that I'm capturing some traffic both on my wireless interface as well as my Ethernet interface. Now we want to capture traffic on Ethernet and we're looking for ARP traffic, and so I'm going to put a capture filter in of ARP, and then I'm going to click the capture and we will start capturing ARP packets. And you can see that things are actually pretty slow at the moment in terms of the ARP packets that I'm capturing. And so what I'm going to do is I'm going to clear my ARP cache. And I do that by going into my Windows command prompt and entering this command, netsh interface IP delete ARP cache. So my ARP cache has now been deleted, and we're going to see more ARP request responses coming in. Now I'm going to expand my ARP resolution protocol in the details pane, and I want to add a couple of columns so we can see what's going on here. The first one I want to add is the ops code, so apply as a column, and then what is the sender IP address, so who is sending this, so I add that, and I want to see the target IP address. Click this to resize everything so we can see it a little bit clearer, and you can start to see now that I've got requests and replies going on. I'm going to stop this capture for a moment and scroll up to the top. Let's take a look at this first request and reply. So this request is from my gateway router and is going to my desktop computer and is saying, what is the hardware address for my desktop computer? And if we look at the request, you can see that the target MAC address is all set to zeros. So it's saying this is what I need. If we look at the reply message, you can see that my desktop computing is replying back to the gateway router. And embedded in that message is the MAC address of my desktop computer. So when the gateway router receives this message, it will update its ARP table. What is interesting in this message is if we expand the Ethernet header, and indeed you can see it in the packet list window as well, you can see that this request is not a broadcast, but is actually sent directly to my desktop computer. Why is this? Well, this request is an ARP request, but the gateway router already has my desktop computer in its ARP table, and it just wants to make sure that the ARP table is still accurate. Now if we come down here to packet number 6, and you can see this is a request from my desktop computer to the router, and remember I cleared my ARP tables. So if we look at this request, you can see that yes, it is being sent to as a broadcast. It's being sent to everybody because I don't know what my gateway router's Ethernet address is. And so here you can say I'm requesting this, and again you can see the target MAC address is all zeros because this is the information I'm trying to acquire. The next packet you can see is a response back from my gateway router, and you can see is providing its MAC address. If I want to filter on things going backwards and forwards to my desktop computer, then I can filter on my desktop's MAC address. So I say select that, and that is my destination address, and I really want it going to and from my Ethernet destination address. So I'm just going to rename that filter to say Ethernet address and hit apply. And you can see that 22 out of the 29 packets I captured were indeed going to or from my desktop computer. And so this gives me a much better picture of the requests and replies that are happening to my desktop. Now if I want to see things that are not going directly to or from my desktop, but my desktop can still hear, then I would say does not include that address. And now you can see the broadcast messages that are being sent out by the switch to all the nodes on the network, including my desktop computer. So for example, this request here is from my gateway router that's looking for this target IP address. And so it's sending it as a broadcast message, and it's saying, please give me the hardware address of this IP address. that arrives at my desktop computer, because it's a broadcast message, my computer says I don't own that IP address. The IP address of my desktop computer is 192.168.1.3, and so it discards this ARP message. So I have started a new packet capture, and I'm going to let it run for about 5 minutes so we can take a look at how often I'm updating my ARP tables. Okay, I'm back, and you can see that I've been capturing for about 5 minutes my packets, and so I'm going to go ahead and stop this packet capture. Now I want to focus in on this last request reply that you see. This is from my desktop computer to my printer, and then you can see the printer responding back to the desktop computer. So I want to filter and look at all the messages going backwards and forwards between my desktop computer and my printer. And to do that, I'm going to filter on the addresses. So I say select, but I just don't want destination address. I want it to be the source and the destination address. So I'm going to say that Ethernet address, and then I want it going backwards and forwards also to my printer. So I also want that address, but again I want it not just the source, but the source and the destination. So I change that and I hit apply. And now you can see all the requests and replies that are going between my computer and my printer. Now I'm going to change the time view to say seconds since previous displayed packet, and what you can see here is that I'm making a request. Very quickly I get a response back, and then about 60 seconds or 1 minute after I made the previous request, I make it again. So you can see that my computer is sending an ARP message about every 60 seconds, about every minute, to the printer to say, what is your MAC address?